How is it going, everybody? So my name is KelilGotSauce, and I'm gonna be your instructor for today. This should be a pretty short and sweet lecture, not too long, max 20 minutes. And today we're gonna be diving into React hooks. What are React hooks? How do we use them? The different types of React hooks. And we're also gonna be doing a quick little intro on pure functions, just to kind of like ease into the use cases of the use effect hook. So before I get even started even deeper, let me just do a little quick introduction. So like I mentioned before, my name is Sakir Kalo, born and raised in Montreal. I don't know if there's any Montreal students here, but I grew up, spent my whole life in Montreal, Pierrefonds, then I moved to LaSalle. Ended up going to school at Queen's University, studied computer engineering while also playing football. So I'm a really big football fan. Played wide receiver, slot back, tight end. Had a blast playing for Queens. We even made it to the Yates Cup my senior year, which was crazy. Also dabbled in track and field. Also super passionate about music. I'm actually currently in a music studio. The reason why is because the acoustics in music studio are actually perfect for teaching. I realized that last year. So I do all my lectures in a music studio. It just gives out the perfect quality from like a sound perspective. And so when I graduated university, I spent a lot of time freelancing, building websites for companies, blue collar restaurants, music studios as well, record labels, stuff like that. And I got picked up about a year ago by Concordia University. They had a web development boot camp and they needed some instructors. And I spent 3 semesters teaching at Concordia University, and I really enjoyed it. I love coding. I love to problem solve, and I got to meet a lot of really cool people, a lot of cool students, and I really had a blast. And I also did some teaching at Lighthouse Labs, which was like the same kind of format: mentoring, teaching, problem solving, debugging, giving lectures, one-on-one sessions, tutoring, all that kind of stuff. So I'm pretty comfortable when it comes to that. And what else can I say? And yeah, I'm really excited to be teaching at Promineo Tech. It's gonna a great opportunity for me to meet new people and to just share the love of coding, and just learn a lot. So that's it for me. I really hope you enjoy the lecture. If you have any question at any point during the lecture, feel free to put it in the Zoom. And if you have anything regarding the sound quality, or you need me to zoom into the screen, or you want me to repeat myself, feel free to let me know at any moment in time, and we can do so together. So without further ado, let's get right into the lecture. So the first topic that we're gonna tackle on today is pure functions. Is anybody familiar with pure functions? Does that ring a bell for someone? Has anybody seen or heard that kind of notion before? No, okay. So pure functions, a good way to think about pure functions is procedural versus functional programming. So when you write code and when you're solving problems, there's multiple techniques and ways of doing it. There's procedural programming, which is writing if-else statements, writing for loops to solve a certain problem. And there's also functional programming, which is simply relying on creating small and efficient functions to solve your code. So when we talk about pure functions, we're referring to those small and simple functions. And those pure functions have a few attributes and a few rules to them. And let's talk about it real quick. So pure functions, like I mentioned, are small and simple functions that perform a specific task. And this can be from like calculating the sum between two numbers. This can be something like calculating the number of letters inside a string. It could be anything, but it needs to be simple and it needs to be efficient. It needs to perform one specific task. Another thing is when it takes in identical arguments, it needs to absolutely return identical returns or have identical returns. What I mean by that is if I have a sum function that takes in the number one and the number two, I know for a fact that 100% that function, if I give it the number one and the number two, I know for a fact that I'm going to receive as a response, as a return, the number three. 100%. This is why the sum function is a pure function. If, for example, the sum function also added number one and number two with a random number, then that would make the sum function an impure function, because at that point I can give it two identical arguments. I can give it number 1 and number 2 and get number 7 as a result, or number 8 as a result. So because of that, you can't predict with 100% accuracy what the result's going to be, and that's why it's an impure function. The third property of of a pure function is that it has no side effects. What's a side effect? What do you mean by that? Well, I'll explain. A side effect is four things. There's four conditions to what makes a function have side effects. The first thing is, does it have input-output operations? Input-output operations is anything related to your computer communicating with the outside world. Take a console.log, for example, which is an operation where the computer is able to send information from the computer to the outside world. That's input-output operation. The second thing is referencing or mutating outside variables from inside your function. For example, if I have let x equal to 0 outside of my sum function, and inside my sum function, I am adding x like so, then this will make it an impure function because I am mutating the value of, what am I saying? If I'm doing something like this, then this would make sum an impure function because I am mutating the value of a variable that is outside the scope of my function. The third thing, you could also do the same thing with arrays and objects. That's also a big no-no. And the last thing is, if you're calling an impure function from inside a pure function, that makes the pure function be an impure function. What I mean by that is, if you have a function called sum, which is currently pure, right? Like this is a pure function. However, if you just simply add an impure function, like random, inside of my pure function sum, then sum now becomes an impure function. A good way to look at it is almost like diseases. If you're healthy, but then you eat something that has a disease inside of it, then you become unhealthy, then you have a disease yourself, right? That's a good way to think about it. So this is like a little quiz of like pure functions versus impure functions, but I think that everybody kind of gets the basis of it. So now let's dive into React hooks. So the main definition, or a good way to think about React hooks, is this following definition. So React hooks are pre-built functions that allow us to tap in to the many React features like state, for example. So useState is a very popular React hook. Without states, we wouldn't be able to re-render the information in on our websites, on our React websites. So they're very useful for that. And React hooks allow us to basically tap into the pre-built functions that React comes with. And there's three rules when dealing with React hooks. The first one is don't forget the use prefix. So out of all the React hooks, you'll notice that they all have a use prefix, use state, use effect, use context, use reducer, use ref, and there's many more. The three most popular are use effect, use state, and use context, but you'll notice that they all of them have the use prefix in front of them. And even when you start building your own custom hooks, you're gonna want to use the use prefix, no pun intended. You're gonna want to use the use prefix in front of it, right? That way, everybody knows, from the developers to the team, everybody knows like, oh, okay, you're dealing with a hook. You understand that like, okay, like it's a hook. You know how to treat it. Second thing is you only call hooks at the top level of your function. For example, this is actually another example that we'll see later, but if you have your use state, you're not going to put it at the bottom of your function, right? That's not, you're going to get an error if you do this. You absolutely have to put it at the top of your code, like so. And the second thing is you also can't conditionally initialize your use states or your React hooks. You can't put them in a condition, right? If you're going to use them, they have to be outside of a condition. So that's it for the React hooks. Everybody good with that so far? Awesome. So we can dive into the use effect hook. So the use effect hook notice that it uses the effect keyword, which ties into the side effects that we've seen earlier on in the lecture. So the use effect is a hook that was created to kind of to kind of counter the side effects that we would be dealing with in our code. So the use cases for the use effect is when you're dealing with timers, set interval, set timeout, when you're fetching data from an external source, or when you're dealing with console.logs, right? Those are like the most common cases of when you can have to use the use effect. So now, how do we initialize the use effect? So we know that when you're dealing with use states, you initialize them like this, right? But when you're dealing with use effects, you have to initialize them in a different way. And you use this syntax over here. This is like the general equation for the use effect. So the use effect takes in two parameters. One is a callback function, and the other is an array. And a good way to look at this is that the callback function is the what, and the array is the when. So depending on what you put in the array, that's gonna decide when this callback function is called. So if you don't put anything in this dependency array, this callback function gets called only when the functional component, aka this thing. So if you put nothing in the dependency array, this callback function will get called only when the functional component gets mounted. Only when it gets mounted, that's it. If you put something inside, like a state, then this callback function will get called when it gets mounted, when the functional component gets mounted, or when a state changes. So every time that the state changes, this callback function will get called as well. Small pointer. And if you have multiple things in the dependency array, like state 1 and state 2, then this callback function will get called when state 1 changes or when state 2 changes. And if you put nothing in the dependency array, then the callback function gets called whenever anything changes. So if you have three states, state 1, state 2, and state 3, whenever state 1 changes, this gets called. State 2, this gets called. And state 3, this gets called. So when there's nothing inside, it's the same thing as putting everything inside of here. So nothing is the same as everything. A little bit of a mind bender, but you'll get used to it. And the last but not least, we have the cleanup function. And this only gets called when the functional component gets unmounted. So what do I mean by mounted and unmounted? Because that could be a bit confusing. So when referring to something being mounted, we're referring to, and that's the end of the lecture. Thank you.